Hi guys, welcome back. In section 20.12, you'll learn about some of the properties of alcohols and some of the ways that we use alcohols. Again, in chemistry, alcohol doesn't necessarily mean wine, beer, and liquor. Alcohol is a class of molecule, and you may recall that alcohols are identified by this oxygen hydrogen. This OH group is what makes a molecule an alcohol in chemistry. The two most important alcohols, at least from a maybe an industrial point of view, are methanol and ethanol. These are the two smallest alcohols, and we'll take a look at how we produce them and what we use them for, and then we'll look at a couple of other alcohols that have some interesting and common uses. So here's one way to make methanol. This might be the most common way industrially. This molecule right here is carbon monoxide. You can see the black is carbon, the red is oxygen, and there's a triple bond. Triple bonds have a lot of energy stored in them. It's also a very strong bond. Carbon monoxide is toxic. It's a very dangerous molecule to people. When we breathe it in, to be honest, I'm not quite sure what's happening, but I believe it is somehow replacing oxygen. So if you inhale air that has carbon monoxide, your lungs preferentially absorb the carbon monoxide instead of the oxygen. And the result is, even though you're breathing, your body's not getting oxygen and you end up suffocating. But you might want to talk to a medical doctor about that. Anyway, you start with carbon monoxide. Um, One more comment on carbon monoxide. If you are burning natural gas in your house to heat your house, for example, or maybe in your water heater, or even in a stove, if you have a gas stove, cooktop, I should say, you should have a carbon monoxide meter, almost like you have a smoke detector in your house. For fire, you should have a carbon monoxide detector as well. You react the carbon monoxide with hydrogen. Now, hydrogen, as you've seen in class, is very flammable, very combustible. And so you take two really pretty potent gases and you make methanol out of them. And it works, right? Here's one carbon, one oxygen, four hydrogens, four hydrogens. So you make a molecule of methanol. This is often referred to as wood alcohol because if you're making your own alcohol, you don't want to drink this methanol. It's very toxic to people. Ethanol is made in a very different way. You start with this big molecule of sugar. This is glucose. The sugar can come from a variety of sources. Quite often we use grapes. We might use wheat. We might use potatoes. We might use corn. But you've got to have some sugar. It could just be, cane sugar, for example, or beet sugar. And then what's missing here is the yeast. And so you would add yeast. The yeast is a living organism that takes this sugar molecule and metabolizes it. In other words, it turns it into carbon dioxide and ethanol. Now, the ethanol is the molecule that's in alcoholic beverages. So if you go to the liquor store and you buy something, you're buying this molecule, right? Quite often, the carbon dioxide will give a bit of fizz. If you open a bottle of beer, for example, it's going to have a certain amount of fizz to it. If you open a bottle of champagne, the carbon dioxide is providing the pressure that pops the champagne cork off. But not all kinds of alcohol that you would buy at a liquor store have this carbon dioxide either. It's a process of fermentation. Notably, if you buy spirits, vodkas or things, tequilas or things like that, there isn't carbon dioxide. And here's the reason. This reaction depends on yeast converting sugars into ethanol. Now, what happens as the yeast ferment or process the sugars, that the percentage of ethanol or the concentration of ethanol increases. And once you get up into the mid-teens, 13, 15, 17% ethanol, the ethanol is toxic to the yeast. And once you get up into those, teens percentages, the yeast simply dies. And when the yeast dies, then the reaction stops. Yeah. And, and so what happens here is you can use this chemical reaction, this fermentation process, to produce alcohol percentages or ethanol percentages up to 13, 15, 17%. If you want to have a higher alcohol percentage than that, um, you've got to distill it. And that's why you hear people talk about stills or distilled spirits and things like that. In principle, using a distillation process, you could get the alcohol percentage or the ethanol percentage up to 100%. You just distill in the ethanol is going to boil off first and leave the water behind. Anything else? No, I don't think there's anything else to say about that process. So there's one process to make methanol, a very different process to make ethanol. And in fact, if you're making ethanol to burn, like E85, it's again another process. You start with this molecule, which you may recognize from section 20.8. Was it 20.7? One of those. This is ethylene with a double bond. And then you react the ethylene with water, and sure enough, you get two carbons, one oxygen, two, four, six hydrogens, two, four, six hydrogens. So this is another reaction that makes ethanol. And I believe, now please let me know if I'm wrong about this, but I do believe that if you were to go to the ethanol plant that's just on the other side of Grove City, this is the process that they use for that. But again, if I'm wrong about that, please let me know. Here are a couple of other alcohols. This is an antifreeze molecule, but the chemical name for it is ethylene glycol. It has two alcohols, one on the right side, one on the left side. This is not a molecule that's safe for people or really anything, any other organism to consume. From time to time, you'll hear about pets getting into the garage and getting into some antifreeze, and it's not good for them. It could even kill them. You certainly don't want to have your antifreeze lying around where kids could taste it because I believe it's got a slightly sweet flavor to it. Again, if I'm wrong about that, correct me, but I seem to remember hearing that somewhere. So this is a pretty simple alcohol molecule. Here's another one that you can go down to any gas station or grocery store and buy. It's called rubbing alcohol. Sometimes this is also called isopropyl alcohol. In fact, if you're reading a label on a bottle, it'll probably say isopropyl alcohol. And this is sold in different concentrations. Sometimes it's around 70%, but you can buy it up to 90-95% concentrated. It's good for sterilizing surfaces. It's good for cleaning. You could put it on a cut or a scrape or a bruise, but it's going to sting like crazy. That stinging is, I suppose, what's cleaning out the bacteria. This could also be called 2-propanol because the functional group is attached to the second carbon, and since there are three carbons, propane becomes propanol. So this molecule has three names: rubbing alcohol, isopropyl alcohol, and 2-propanol. So those are just a few of the common uses for alcohols and a couple of their properties.